Hello and welcome back to Google.rs. It's Byron speaking. And I've been taking quite a break here because it felt like, I felt like I can't solve this. I felt like I gotta do something else for a moment. And so I did. And I think, I've done some research. And what am I actually talking about? I'm talking about this problem here. We have this JSON enumeration. And as it happens, an enum you want to unpack all the time. And thanks to the borrowchk, this doesn't or isn't so super simple if you're dealing with mutable borrows. And we take a mutable borrow of the top level value, and then we try to descend into the variants, which happen to be objects, and then we edit or we change the hash map contained within to either return an existing value of a given key or add a new one and return that new one instead. This will be taken as the next one. Well, I think I should look at this. This will be taken at the next one. Oops. This will be taken as the next one, and then we basically dive in. So in any other programming language, I would just do it like this. Really, that's it. So you just go through all the fields that you want, then you either insert one or get the existing one, and then the result of this you assign to your loop variable, and then you keep going with the next field naturally. So that's the natural way to do it. That's how I've always done it. That's easygoing and works very well. But not so here, because I was just trying around with this a bit off camera just because I want to get an understanding or want to get an idea of how I can possibly do this. So here's another thing. I can't reassign this object, so I'm kind of assigning to a mutable version of this. So it's basically a mutable assignment to a mutable borrow. That's how you can imagine this. So that way I can reassign it, but if I want to compile this, yes, and I'm still having this silly bug that causes everything to recompile all the time, but it might have gotten faster compilation. There was, I'm on the latest, greatest, and it seems that it's a bit speedier now. Previously, it was like super slow for whatever you did. And are you kidding me? Excuse me? I just compiled this? All right. Is this real? Am I dreaming or something? Because here I go in, and then whatever is contained in this mapping, I return, and then... Really? This didn't work previously, man. That's awesome. So, yeah, I had another idea of how to do this. Okay, so this recompiles all the time because the cargo doesn't know anymore that it's actually clean for some reason. That's not so nice. But yeah, actually this works. I can tell you this didn't work previously, I swear. Or I did a silly, stupid, dumb mistake, but something is wrong here. I mean, it's great that this works because that's what I wanted. Okay, let's try to use this, because now the next step is to actually match on this. And we assume to have a mapping in here. This is what we get, what we create. This is supposed to be this obj here. This is why that works. Because I have a let here, I have a local binding, so I actually forget what I had. See? So now this will not work anymore. So this is what I wanted. I just had a local assignment, so I created a new obj each time and basically forgot the previous one, which is the object above. So now it gives you the borrow issues that prevent this from working. Yeah, it would have been too nice. So this is what I want, but I can't have it. So I thought, okay, let's see if we can do this with recursion. Because possibly then the borrow checker will understand what's going on. And it's kind of a, I don't know if it's tail recursion or not, but I think what we have to do here is to provide it with a slice of keys, and then we take the first key, go down, and then we go into recursion. So that's our next one. And where's the first key? The first key is here. I just access it directly because we assume this has always one left. And if not, we will not recurse anyway. So here is this, this is keys. 0 to owned, okay. And now we have the next item in here, in next. And now we go into recursion, and I hope that will work. Because it should then realize what we are doing here and kind of, not mess around with that, with us too much. And obviously we want to return, let's first return nothing. Because I have the feeling that if you return something, the borrow checker might realize what we are doing and then prevent it, but I want to see how far we get before I ask on Stack Overflow. But the mutability is the problem. I've checked cert, which defines the data structure, and cert will do a lot of stuff, but it only acts on it in a read-only fashion. And I really just want to have a mutable thing that is deep down the belly here. And I was thinking about ownership as well, like taking an own version of this, that this just shifts the problem around a bit, I have the feeling. So anyway, so here we have next. That's terrific, like this. And now we can do our recursive descent, but only if we have more than one. So if more than one key, if keys lang greater 1, then we do that. And for now we have no else case because we have no return. Otherwise we would just return what we have. But we will do this in the next step. So now we go with keys. We slice it from 1 to the end, like this. And then we pass the object that is next in line, and then it will do the same thing again. And that's kind of the algorithm. And in theory, what happens here is that we can do it like this. We say let obj be our recursive descent of okay, that's a vector, so we want to slice it, of our own vector here, of our own slice, of a slice of our own vector, which is the field names in order, and our object, which is what we get initially. Oh, and now I have to start, let's just start the descent. I will make the assignment later. Let obj be this, but for now I won't do it. And this is just something that might work, at least for now, until we actually attempt to return something. But mismatch types, okay, so we have a, so we don't have a slice here. I'm always unsure how to get a slice as slice, if that is now the right way to do it or not. I kind of like a slice. Oh, interesting. Interesting. Well, then I think we have an iterator, huh? A second iterator. Because then we can do the mapping ourselves. Oh no, wait. Actually, if we have strings here, then we don't take an iterator and convert it to a slice here. Then we just say, well, whatever we get here, it's interesting that it doesn't give borrows on these, that it contains the actual strings. But it's read-only anyway, right? So it's fine. Yeah. So that's what happens here. So now the type should work. See, it's unstable. Damn it, I hate you. Yeah, well, then I take the other slice syntax. The one that I find a bit cumbersome. Okay, here we take a slice of everything and borrow it. So that's how it goes. The deref coercion didn't... Oh, wait. The deref coercion didn't work last time because we had the wrong type. Maybe it works now. I'll do that again. It seemed that it actually compiled, but let's wait until I have a return value here. Because then, yeah, let's see. It's really about borrowchk recursion rules something. To see whether or not that will work. Okay, that compiled. That's very good. So let's try to make the assignment then. So here we assign actually the same. We return the very same thing, a mutable value, and it wants to be mutable because we want to change that after all. And now we happen, and that might be a problem. Now we happen to have two. Now we have aliasing basically. Now we have the object available for writing, and we get something that is part of the object also available for writing. And this is where we should have a problem. So either we return this or we return next directly. So this is now our return value, and that's how that goes. But, and as you can see, it's kind of, if this doesn't get optimized away, that's kind of a very expensive way to do what I did previously. What I did previously was much nicer to do. And oh wait, that is interesting. What? Say again. Let's say read again. I've never seen that message before. So, missing lifetime specifier. Okay, this function return sub contains a borrowed value, but the signature does not say whether it is borrowed from keys or object. Ah, this is how that works. Well, I think now we tell him what the borrowchk wants to know to actually prevent us from doing what we're doing. No, I don't wanna. Let's call it V for. Sorry. Damn it. Let's call it V. Yeah, well, but he's very precise. He's asked exactly, or he said exactly the right thing. So great work on the compiler there. I love it. Even though now it will not love me anymore. It will tell me that this doesn't work. I bet. Just because I have two, I can write the same object from two different pointers, right? But it works. It seems to work, actually. But okay, that works. That's awesome. So we have successfully executed that thing. It's weird that this doesn't work. I mean, I really would like to have. I mean, why do I have to do recursion? I would like to ask that question on Stack Overflow. Definitely so. Because I prefer the other way, which is just easier on the resources. Because all that slicing here is totally unnecessary, and it's just that we can't do it in a loop, That's a problem. Oh. Man. So. Yeah, well. Let's try to work with this. Let's see, maybe the borrowchk will hate us once we actually use this. So here on obj we get a mapping, and then we can start to assign values based on the information we have in our JSON type info, right? So let's see if that works so far. And I would still expect the borrowchk to tell us we can't do it. Because technically, but maybe it is able to understand what's going on. Maybe it's not that dumb, I'm saying. And I would never say the borrow checker is dumb. It is a great analytical mind, kind of, but still. You know, if I was him, I would kind of say, well, you can write potentially the same object from the same, from two different borrows, and that's not supposed to be allowed, right? But apparently it is. Well, okay, so under these circumstances, I don't actually need this. Let's just go in here like that. And then once we have a mapping, we can now assign to that mapping. That's going to be gorgeous. And match on the type info. Oops. J type. Actually, no, we don't do it on the J type, I guess. Well, you might need another function that deals with the parsing of the respective value for us. Yeah, but let's go with the complex type here, because I think that's more important. Because first we need the container value if there is one, so that's complex type. Complex type pod, which is the simple case. And we have complex type vec, which is where we want to push stuff. And then we have complex type, come on. Complex type map, I think. Yep. Complex type map, where we will parse the second stage basically of the value that we have here somewhere, and go ahead setting a nested, another nesting level basically. This is what we will do. Yeah, so let's see if that works so far. I'm curious. Here is the match. Oh wait, that's the match. That's the end of the match. Return value is nothing, so from that point of view we are good. And this is something where a comma is desirable. So let's see. Yeah, and then I think I want to have a generic function. No wait, it's determined at runtime. What I want? No, wait. No, actually I want to have a... I want to have a generic function that parses the right thing for me and returns the right value. So it's more like, where is it? Arg from string. So this is all we need. Oh, damn it. Well, you know what? Considering that it's just from string in the end, which could fail. So we want error. Yeah, the parsing can still fail, or the value parsing. So we definitely need this error structure here. Arg name, arg type, that's something we have. We don't have the arg type yet, but we have the arg name, which is the field. Yeah, I think parse error, arg name, arg type. I think that's the field name. Yeah. The field name. And the arg itself, that's the value. Yeah, but we need this. I think then we are good. Where t has from string and default. Yeah. So that does the right thing and handles errors kind of smoothly. This is what it needs. Okay, so we need that. Where is it? We need, I think I want to go a bit further here. Let's give them some space. And then I want the error. This also means that in the engine macro, I want to set JSON value. I want to pass on the error. Mat error. We're good on that level. At least. So finally, I can think of, now we have to basically match on the type, but I think I want to put the match somewhere else. I want to have a function that returns a new JSON value instance that I can then just use to put in the way I want to put it in, depending on the complex type. To JSON value, and what we take is, actually we can bind our surrounding. The value, no, we can't bind it, because here in the mapping part we will say let key value be parse kw value blah blah. How's that working? kv error for hash map. Yeah, for kv error and then true. And so we want to pass this value here. Oops. Along. Then we pass on the error information, where it will push errors if it can't do things, and then true, because it is for a hash map. This will return what again? I think a tuple, right? Tuple of a string and optional, which is key value. That's fine, but that's what we want to work with. And this, oh, actually, wait, we bind it read only. So yes, we can also use it here. I was thinking, okay, because I use the value down here, I can't use it here, but it's a borrow, immutable borrow, so there is no problem with that. We can use it in as many places as we so desire, as long as there is no writer. And there is no writer to it, because otherwise there would be complaints from the compiler already. Cool. So to JSON value, yeah, I think we want to pass it a JType, which is a JSON type. And yeah, it's just a borrow of that, because, well, let's see if we can, because we only need it once. And I actually don't mind to decompose these things if I use them anyway, so then I just pass it along by value. In this case, it's non-copyable, so I don't care. But the point is that this should possibly work, because we use it exactly once per branch, and it might be able to figure this out by now, but I'm not sure. Yeah, so what we return is a JSON value. Here we go. Nice. And that is that. So for now, I think, well, let's do the match JType. And then we have JSON type. We have a few of these. Let's bring it up. CLI common. So if you have a Boolean, the thing is we just need one kind of way to parse this anyway, but it will look very similar in all cases, I think. And type inference can do the job for us. That's also cool. So in that case, we say JSON value, and that's our return value as well. Value. Oh, sorry, not like that, but like this. I have it up here somewhere. And then we say, okay, it's bool, right? And in here, we can now say arg from string, I guess. Arg from string, it's a bit of a misnomer. Yeah. Arg from string. Arg from string. Just want to get the first one right. Okay, so error we want to adjust mutably, though. Because we pass it on twice. And if we bind it here, then it's bound and we can't use it here anymore. So we have to pass it. We have to pass it directly. Error is a mut invalid options error. Like so. That will work. 2 arguments we have to pass to get this to get what we want. Still okay. So here we can use the value, fortunately. Then we pass on the that we get. Arc name. Oh yeah, the field name we also have to provide. What we could do, oh no. Wait, what we could do. We could get the field name. We could actually define this thing here. Because, sorry, in this branch, where we know that it's an object, where we know that we can do work on it. Oh, I lost my clipboard here. Like that. And now we can unpack and prepare the values that we need and bind them right away. Like that, yeah. I think that will work. So the arc name, yeah, the archetype, I don't know yet actually. This is something we have to convert probably back, or we need the string value for the archetype in our function call because we have been converting this already. And yeah, actually we don't know anymore. We don't know that precisely. So we are degenerating information there. But I think I wanna convert this to a value, to a string, using the asRef functionality. So I will implement asRef str for the JSON type. Yeah, that's what I will do. It's a bit hard to read here for some reason. So that's recursive descent. Okay, so here I need to get the field. Let's field name be. We know that we have at least one here, so that's totally fine. Yeah, so let the field name be self 0 and then self lang -1. So we want to access the last item here. And that should, we want to borrow. I think that is it. Otherwise, I don't know if that wants to return a borrow or not. Let's let the borrow checker tell us. So now we have access to the field name and can pass this here. And I do hope it knows that I would like to return a string slice here. And the type to be done. The JSON type, and that's it. So that's our call here. Okay. And I will implement a default here. Sorry, just so that I can see if that actually compiles before I start copy pasting stuff. And I also guess I would like to put this here to have some more space. We are too far to the right here. But that could be it, I think. Give me the no word wrap treatment for now. Good. So here we go. And then in that case, I shall return a JSON value null, which is the default, which should make it compile if it can compile. To JSON value. Okay. And now I can try to make the call that in the simple case. Yeah, I think I go with the entry form again. So we give it the entry or insert. And the object we insert will be whatever we get returned. So here it's really, really simple because we have no by the way, yeah, we always have a top level struct, but then individual. Yeah, so this is always a mapping here. I'm just trying to remind myself of the structure. It's always a mapping, and this mapping might contain a value that is not simple. So in any case, this is just an assignment here. So here we go with mapping entry. So the field, we go with let's go with field. It's shorter. And short is good. Now we can live without verb. Still to be done. Now we can live without verb at least here for now. The cool thing is that I think that type inference will do the right thing for us. It knows there is a bool, so it will call this with the respective type automatically because it knows the return type. And arg from string returns AT, so that's totally cool. Totally so. Yeah, so here I'm confident that this can do something useful for us. And now here, this part. Entry, field to owned. It's very unfortunate in a way that it's a string here. I understand why, but it's unfortunate because just to see if something is in there, we always have to pass in an owned item. Because, I mean, in this case, there are better ways, obviously. But considering we take the shortcut here, this item that and the entry receives is either already in there, then it doesn't need to own it. But if it wants to create a new entry, then it has to own what we pass. And this is why this is what it is. Or insert. And now we can just say to JSON value. And pass on the JSON type, which is... Yeah, let's see if that works. I don't know. Ownership could be making it difficult for us because now we have to access for takeout basically and move for moving the J type here, which could work, but I'm not sure. Considering we only take the children out and don't try to access the type info afterwards anymore, this could possibly work. I always want to try. If I'm unsure, I want to try. Let me pass on the error for just this call. And to JSON value, because it's internal anyway, let's call it to JSON, to J value or something, to JVal, just to keep it short. Okay. Or we insert a JSON value, which looks like this. All right. And we are not interested in the return value. If I would leave this like that, we would change the return value of our match to the mutable borrow of this JSON value that we created. And this is something we don't want because we're not interested in that. Okay, so in theory, once that works, generally, once that compiles, then we can go ahead and fill in the remaining cases. But I'm not sure if that will work. Okay. Can capture dynamic environment if in an FN item. Oh, right. True. I always forget that. Well, then let's mut. Is it mut? Does it need to be mut? No, we don't manipulate. I don't know. Let's see. Let's try without. So here we go. So I think that's how this would look like then. I think that's the form. Actually, it's rare that I have such a complex one, but I think that's how that would look like. Then it's an assignment as well. So we have to put it here. And as usual for assignments, I really like to just move this one to the right here, just to make clear what's happening. And yeah, now it could possibly capture a dynamic environment. Field is unresolved. Oh yeah, that was just a follow-up error. Good. So type common field cursor does not implement any, yeah. I mean, null. There we go. Lots of candidates there for the slices. Good. Closure may outlive the current function, but it borrows field, which is owned by the current function. So wait. Closure may outlive the current function, but it borrows field. So the problem is that field does not live long enough, basically. And I wonder why, because technically it's created first, right? So it should outlive the thing. Field is borrowed here. But that is not staying there. Or did I set it up incorrectly? So field, that's the arc name. That's a static string. Maybe this is why that doesn't work anymore, because we don't have a static string. We don't have static strings here. Yeah, well, that does not work. So I have to postpone this. I don't want to change too much at once. That's the point here. I just want to make this compile. So we don't use it for now. And we might have to change the static thing and make it to some other lifetime that I also don't yet know. Some lifetime, right? A and B maybe, I don't care. Or I could just go with A and this should also work. Anyway, at least for the duration of the invocation, it will then be valid. Yeah, that could be it. That could work. But let's see if that works better now. Ref field. Okay, we are trying to move something that we shouldn't move. Can I move out of indexed content? Oh, it tries to move. Interesting. So now it shouldn't anymore. To prevent the move, use ref field or ref mat field to capture value by reference. Really? Cannot capture mutable local variables, mutable main 87. That's temp cursor. Oh, yeah, that's my bad. I think the point is that this is already, it's kind of a double mat that I did here. This doesn't work. Okay, so now we should get a bit further, but I think we just see different errors now. Will we? Seems to work. It's compiling for too long to not work. That's always a good indicator. Come on, you can do it. Come on. What the? All right. Here we go. So now I would be willing to say, well, we have A, and then this is just going to be A, and that's all there is. So let's see if that generally works. If it does, I can see if I may pass the field here. Whatever field is, I don't know the type of that thing right now. Okay. Cannot infer appropriate lifetime for automatic coercion due to conflicting requirements. First, the lifetime cannot outlive the lifetime A as defined on the block. So the static had its purpose. Cannot infer appropriate lifetime for automatic coercion. That auto reference is valid at the time of borrow. So we are trying to pass it on, but this parse error, let's see what, this parse error, it owns this stuff, does it? But apparently it does not, otherwise it would work. So struct parse enum. Where is this? It's in common. 357. Okay, so it's a so it's a CLI error underneath. So how is that defined? Enum CLI error. Then we have a parse error. And it wants to have static strings. And in the moment we try to add a parse error, then we have conflicting requirements. Because that's static for a reason. That's the thing. And now I can't afford this anymore. Basically because I don't, yeah. Okay, so what I have to do here then is to make it strings. Because I can't go with a here. Well, maybe I can. If I add the lifetime a to my enum, I could possibly say, well, it must live as long as my enumeration member. And I don't know if that works in general. I also don't know if I want that. Let's see how often we use this. Let's see how much code is affected. Okay, not much it seems. The engine, does it use a parse error? No. Okay, so we do it. Let's just convert it to string. CLI error, here we have display. Yeah, because if I add a lifetime now, I have to add lifetimes everywhere, and that's something I don't want. So I rather go with the cheap stuff. It's an error handler, so it's kind of, you know, performance isn't critical here at all. Premature optimization is bad as well, so let's go with string and string. Let's see where we do deal with the parse error. That's a ref now. That's also a ref. Then we are good here. Here we say to owned and to owned. And now lifetime wise we should be better. That's the idea. And it looks pretty good. It looks good. Yep. Yep. Cool. So let's implement a few more of these conversions here. Okay, that's my closure. So basically it's just this, but here I can say, okay, we have booleans. We have ints. Let's put these in quickly. I think it's more like copy paste int, and then we say JSON value. Okay, that's I64. And then the rest is type inference. And then we go with uint. And then it's U64. And F64. Oh wait, that's actually float. And here it's F64. And then it's type inference again. And last but not least, it's string. And the cool thing is then we can just say, well, we give you an own version of that string, and there's nothing more to say about that. So we have value to owned, and the string is happy. So that should work just fine. And we still have to deal with the type name. We don't have it yet. But we can have it relatively easily. Oh, look at that. Yep, because I forgot to set a string here, and now it should work. In the meanwhile, we can prepare the display for the type, which shall be impl as ref str for JSON type. And it's as ref of a mutable self, returning a borrowed whatever type we passed here. I think that is as ref, right? Or did I get that? No, that's as simple as that. Cool. And now we again match on ourselves and say, well, what if we are a JSON type? Oops, JSON type Boolean. Then we return Boolean. And we'll just copy paste this around. Then we have int, integer. Let's call it int, so that we can then go ahead and say uint. and make it short like this. Lowercase, not short. So uint, there we go. Then we have float. I think it's, yeah, let's call it float. Even though it would be number in JSON context, but who cares? And this is, for completeness, a string. Boom. So now wherever there's to be done, we can now put the actual type. Actually, I could do the mapping right here. I wouldn't need to do a separate mapping. Gee. Yeah, considering I can do the mapping right here and I don't need it elsewhere, I do the mapping right here. Well, you know, I am dumb. Int, it's even easier. Uint float, and this also shows that the string case never happens, because that's for the error case, right? And we don't have an error case when there is a string. Yeah, so forget that. And there it goes, the code. Haha. Okay, so that should actually be what we want. Unreachable pattern. That is true. Let's kill it. Because previously we didn't have all the cases. Now we have. And that might actually compile. And considering it's like 50 minutes in, I would like to take, or to pause the session and resume the work with the next one. Let's prepare it. It seems to compile. So let's refactor. It's kind of, yeah, it's all, you know, config I think is the main topic here. Log current, yeah, it's config. So let's use config because it's all about that feature in the end. I'm not sure if this is the right thing to do, but that's a big feature that's being worked on. I mean, I'm thinking about the changelog. You know, how will the changelog look like with whatever I do here? Refactor. Improve. Yeah, it's basically, it's more like chore. It's more like, well, chore is build system and everything around it. So yeah, handle recursive JSON value setting. Recursive mat JSON values. Recursively drill down a mutable recursive enumeration without borrow checker issues. The obvious solution doesn't work, but should. Stack Overflow. Yes, I would like to do that. I think I will do it between the sessions. And yeah, then we have the infrastructure to set the actual value with support for arrays, pods, and hash maps. So in total, this is so much easier than the code we had before, and supports much better sharing. That's very, very good. And yeah, I don't have to relate it to a ticket. I think I'm good. That is that. So thanks for watching and have a great day.